Okay, in this video we are going to work on graphing piecewise functions. So first you can see the definition of a piecewise function. It's kind of a non-technical definition there, but it's a function that has different rules. And really by rules, we mean different domains for all the different pieces. So it's like one big puzzle that comes together with a bunch of smaller functions that we've been working on graphing coming together to make one final picture. A few additional notes before we do this first example. We've talked about this, but if you have a less than or greater than symbol, you're going to have an open dot at the specified domain value. And then obviously if you have the or equal to symbol, it is a closed dot. You also want to make sure you use a writing utensil that you can erase. You're going to make some mistakes. You're going to have to erase some things after you've kind of gone through the problem. You'll see what I'm talking about here in just a second. So this first example, we're graphing this piecewise function. It has two pieces. So we're just going to focus on one piece at a time. We're going to give the function x plus 3 when x is less than 1. First thing I'm going to do, and we're eventually going to erase this line, but I'm going to draw a vertical line at x equals 1. This is my boundary line for this problem. You'll notice we use the same boundary for the other piece in this problem as well. This particular function is only going to show up to the left of this vertical line because the rule or the domain is x is less than 1. So we only want the piece of the function there that shows up to the left of that vertical line. One other note that we'll want to add before we do this problem is slope-intercept form. We're going to be using slope-intercept form on pretty much all of these little pieces. Of course, we know m is the slope. In other words, the rise over run, and b is or represents the y-intercept of the graph. All right, so this first example, we're going to start at positive 3, and you'll notice this is a closed dot. All of the dots will be closed except if we don't have an or equal to symbol on the boundary line. So the only time you'll see an open dot is on this boundary line, and in some cases it'll still be closed on the boundary line. The slope for this problem is 1 over 1. Remember, there's an assumed 1 in front of that x there. So that is up 1 and right 1. Excuse me, up 1. Yeah, up 1 and right 1. If we go up 1, right 1, it immediately takes us to the boundary line where, again, we're going to have an open dot in this problem because there's no or equal to symbol with the rule. I'm going to go ahead and graph one more point for this function. So instead of going up 1, right 1, I'm going to do the opposite. I'm going to go down 1, left 1. Since it's a line, it goes both directions infinitely. So that is the first piece. Now I'm going to take the second piece. You'll notice this has the or equal to symbol, so this is going to have a solid dot when we get to the boundary line. It has a y-intercept of positive 4. And I'm going to go ahead and plot this point, but you'll notice this point shouldn't exist in this problem because we only want the part of the line that is greater than or equal to 1. So the portion of the line that we're graphing here is going to show up to the right of our boundary line. So that green dot I'm going to have to erase here in just a second. But from that point, I'm going to use my slope, and my slope in this problem is a negative 1 over 1. If the slope is negative, I always like to put it with the top number. Doesn't go with both numbers. So from that point, we're going to go down 1, right 1. Down 1, right 1 will take us right to the boundary line. Again, that'll be a closed dot. I'm going to go down 1, right 1 again, and then one more time. Again, we're only graphing this piece to the right of that line, and I'm going to go and erase that other green dot. And that's it. That's the piecewise function. We've graphed both pieces. I'm going to go ahead and erase that boundary line the best I can, because really it doesn't exist. Tough to erase it without erasing some of the points that are already there. And you'll find you may not have to graph that boundary line going forward. All right, number 2. Number 2 has 3 pieces. Same idea. So first we're going to graph y equals 1 when x is less than or equal to -4. So I'm going to go ahead and graph my boundary line here at -4. You'll notice it is going to be a solid dot. And we only want the pieces that are to the left, that are less than -4. So to the left of that vertical line. This is a pretty easy one to graph. It's just y equals 1, so it's a constant. It's a horizontal line through -4. So we're going to shift down 4 units and then just graph a few points where the y coordinate is -4. Should be straight. Mine's a little crooked there. It's okay. All right, so the first piece is complete. Now graph the second piece. This one, notice, has 2 boundaries. This one's only going to exist in between -4 and +2. But we need the entire piece. Since it has a left and right boundary, it's not going infinite in any direction. So we need the entire piece of this graph. So this middle one, you'll notice it does not have a y-intercept. So it starts at the point 0, 0, starts at the origin. The slope is -1/1. So that means we're going down 1, right 1 from the origin. Are these open or closed dots is the next thing you need to decide. They're both do not have the or equal to symbol. So you're going to have open dots. So when I go down 1, right 1, this is an open dot. And then we need to do the opposite. We need to go up 1, left 1. Notice how all of these are closed dots except for when we get to the boundary line. It's the only time we don't have a dot that's filled in on these. There's the second piece. And then finally, the last piece, we already have the boundary line drawn. We only want, for this last piece, the piece that is greater than or equal to 2. So this graph, we only want there what's on the right of that vertical line. So the y-intercept is -4. The slope is +2/1, which means we're going up 2 and right 1 from that point. And again, that red dot shouldn't really exist there because of the rule here, x is greater than or equal to 2. So I'm going to go ahead and use it there. It's just a reference point. I'm going to go up 2, right 1. That point there doesn't exist. Up 2, right 1. This is the first point that exists because it's on that boundary line. It's closed dot because of the or equal to symbol. I'm going to go ahead and go up 2, right 1 a couple more times. That piece, we only want it to exist to the right of the boundary line. So I'm going to erase these 2 dots. I'm going to go ahead and erase these vertical boundary lines. Sometimes if you make those boundary lines dotted lines, it's a little bit easier to erase. And there's the piecewise function. Go ahead and try number 3 and number 4 on your own. Pause the video. I'll show the answer here in just a few seconds to number 3. So here's the answer to your turn 3. Those should have a closed dot right here. You do not have to use different colors for the different lines. Go ahead and pause the video, and I'll show the answer to that last one here in about 5 seconds. And here's the answer to the last one. Pay careful attention to where the dots are open and the dots are closed. You should only have 2 open dots, one here at that boundary point, and then one here at that boundary point.